In the following video, I will show you the answers to the AQA GCSE Unit 2 November 2011 past paper. Okay, let's start with question 1 straight away. K is 9, M is -4, work out the value of this expression. A simple substitution. Okay, let's write down the expression with the substitution in it. So we've got 5 brackets 2 multiplied by 9, then subtract 6, and all divided by -4. Okay, so that's 5. Well, 2 multiplied by 9 is 18, and 18 minus 3 is 12, and that's all over -4. 5 times 12 is 60 over -4. Well, 60 divided by 4 is 15, so 16 divided by -4 is -15. Hence the answer -15. Question 2. It tells you that 25.6 multiplied by 32 is 819.2. Out of interest from that, we therefore know that 819.2 divided by 32 should give us 25.6, and 819.2 divided by 25.6 should give us 32. They are the associated division facts to that multiplication. So they ask us 81.92 divided by 32. Well, we can use this up here. We know that 819.2 divided by 32 is that. We've reduced the top number, or the first number in the division, by a factor of 10, so overall our answer 25.6 will be reduced by 10, so I would put 2.56. Next, they want 0.256 times 320. We can use this fact here. We know that 25.6 times 32 is equal to 819.2. Here, the first number has been divided by 100, and the second number here has been increased by 10. Dividing by 100 and increasing by a factor of 10 is overall a reduction by a factor of 10, so the answer is 81.92. It tells us that A and B are different prime numbers, and they're less than 12. Work out 3 pairs of numbers A and B such that this expression, the square root of 2a plus b, is a whole number. Okay, quite a lot to decipher there, but start off very straightforwardly, and in the exam you could get a mark for something this simple. The prime numbers less than 12, write them down so you've got them. The primes that you're considering, well, 1's not a prime, but 2 is, 3 is, 5 is, 7 is, and 11. We'll stop there because they're the only primes less than 12. Now you want 3 pairs of numbers A and B, 3 pairs of numbers A and B, so that this is a whole number. I.e., you want this here, the expression underneath the square root sign, to be a square number, so that when you square root it, you get a whole number. Anything other than the square will give a surd, and you don't want that. So you want 2a plus b to be a square number. Now, what's the biggest? If A and your B, you're restricted to choosing them from here. The biggest 2a plus b would be if you chose A to be 11 and say B to be 7, and you would get 2 times 11 plus 7, 22 plus 7 is 29. So you want the squares less than 29. So write your squares as well so you can see what you're aiming for. The squares less than 29. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. 6 times 6 is 36. It's outside where we need to be. So we've started quite well here. We've got the primes, our numbers A and B, and we've got the squares that we're trying to make with 2a and b. Okay, let's have a go at trying to make some of them. Let's have a go at trying to make 25. So 25, can we make 25? Well, we can if we say, let's say we choose 2 multiplied by 7, which would give us 14, plus the 11 would give you the 25 you're after. So you've got one pair of numbers, A and B. Okay, any other ways to do it? Well, let's try and get, say, 16, for example. How could we get 16? Well, what we could do is we could do 2 times the 7 again. That would give us 14, but this time add the prime 2 and we get 16. So that's another pair for us. And is there any other way we could do it? Let's have a think about this. Well, let's have a go for a different prime. Let's have a go for number 9. Could we get number 9 in any way? It's another square. Let's try and get number 9. Well, we could say, for example, 2 times 2 is 4, plus 5, which is another prime, gives us 9. Because the square root of 25 is 5, the square root of 16 is 4, and the square root of 9 is equal to 3. We've got 3 combinations that give that as a whole number. Okay, so we've chosen A in the first to be 7 and B 11, A in the second to be 7 and B is 2, and A in the third to be 2 and B is equal to 5. Okay, moving straight on to question 4. Quite a simple question here about prices, etc. It says, in May, a coat costs £64. In June, the May price is rounded to the nearest 10. So in June, we're going to round £64 to the nearest 10. The nearest 10 to 64 is rounding it off to 60. So we've got £60. Then it says in July, the June price is reduced by 10%. Well, there are lots of ways to do this. You could do 60 multiplied by the decimal multiplier 0.8 to get £48, or you could work out 10% of 60, which is 6. So 20% of 60 is 12, and then work out your 60, subtract the 12, which gives you your £48. So in July, the price is £48. Ian has 50. Does he have enough to buy the coat? Well, to get your final mark, say yes, Ian has £2 more than he needs. Okay, do state that at the end, this yes, a conclusion for an extra mark. Don't just leave it with 48 and assume the examiner knows that you know Ian can buy the coat. Write down that Ian can buy the coat. Okay, moving on. Question 5. Number or function machine where we put some number in, we multiply that number by 6, and then we subtract 2 and we get an output. The question is asking us to find the number you put in so that you get an output out. The number you get out is 2 lots of your input. So you're trying to solve when the output equals 2 times the input. Right, let's put some number. We can just try and put a number in. Let's put 1 in, for example. 1 times 6 is 6. 6 take away 2 is 4. So our output is 4. Is 4 double 1? No, it isn't. 1, the input number, is not the one we're looking for. You could keep trying this with numbers. It could be a long process depending on how complicated the input must be. Instead, why don't you put in some algebra? Put in an x. You multiply that x by 6, so you get 6x. You subtract 2, so you get 6x, subtract 2. And your output is 6x, subtract 2. Now, we can solve the equation. Well, the output is 6x minus 2, and we could make it equal to 2 times the input, which was x. If we solve this equation for x, we found the input we need to make the output twice the input. So solving from here, I would subtract 2x from both sides to get 4x minus 2 is 0. I would add 2 to both sides to get 4x equals 2. and I would divide both sides by 4 to get x is equal to 2 over 4, or a half. So a half is your answer for this. Let's double check it works. A half times 6 is 3. 3 minus 2 is 1, so the output is 1. The output is double the input, which was a half, so you've got the correct answer. Okay, question 6. A question about money. Julie works 20 hours a week and she earns £7.50 an hour. Okay, well, it seems like we're going to need to work out how much money she earns a week. So let's have a go at this. Her weekly wage must equal 20 multiplied by £7.50. Okay, how would you do that? Well, you could do 10 times £7.50, which is 75, and then double it. So she gets £150 a week. Okay, it says she saves 1/5 of her earnings. So what is her savings? Her savings are 1/5 of 150. So that's 150 divided by 5, which is £30. So each week, her weekly savings are £30. She wants to buy an iPad costing £429. How many weeks does it take her to save enough to buy this iPad? Well, she's saving £30 a week. So what effectively we're working out is how many weeks does she need to save £30 to get £420? £429 even, £429. Well, okay, you could try and do division. You could try and do 429 divided by 30. See how many times it goes in. 30 doesn't go into 4, goes into 42 one time, left over 12. How many times does 30 go into 129? Well, it goes into that 4 times and remainder 9. So it will take her 14 weeks, a remainder 9 to get there. Or you could just see that if this number here, to get it bigger than 429, it would have to be 15. 15 times 30 is £450. She needs to get bigger than 429 to have enough money. So the answer is 15 weeks for this question. 15 weeks. Okay, next question. Last year, 12 students went to the theatre. So 12 students went to the theatre. The total cost of the ticket was £240. So for our own benefit, each ticket is 240 divided by 12, which is equal to £20. So each ticket is £20. This year, 8 students are going. The cost of each ticket has increased by 15%. So it was £20 before. It was £20 before, and now you're increasing it by 15%. So I'll actually write my workings down here. The last year price, we said the cost was 240 divided by 12 is £20 a ticket. Okay, this year, let's do this year. Well, it's gone up by 15%. So let's first of all work out 10% of 20, and I get £2. So 5% of 20 is £1. So therefore, the cost of a new ticket must be, add on the 15%, must be now £23 per ticket this year. And it says they have a total of £200. Can they buy 8 tickets? Well, 8 times 23, let's work it out. 8 times 20 is 160. 8 times 3 is 24. So you add them together and you get £184. answer the question, is this enough to buy 8 tickets? Yes. And you could say with £16 to spare. Okay, do lay your working out nice and neatly. Last year, this year, price of ticket, and work it out and a conclusion so that you get all the 5 marks. The star here means you're assessed on your ability to lay out your answer sensibly and in an understandable way. Okay, next question. Question 8. Multiplying indices, index notation, when the base number is the same, you add the power. So that's y to the 4 plus 7, which is simply y to the 11. Dividing, when the base number is the same, you subtract the powers. So w to the 12 minus 4 is w to the 8. Rearrange to make x the subject of the formula. 2 ways I'll show you here. The first way, what happened to x originally? You took an x, you multiplied it by 3 to get 3x, and you added 2 to get 3x plus 2, and that was y. That was equal to y. So going backwards, what do you need to do to your y to get your x back? Well, you need to subtract 2, so you would get y minus 2, and then you need to divide by 3, so you would get y minus 2 over 3. X is equal to that. A slightly neater way, I prefer the y equals 3x plus 2. Subtract 2 off both sides to get y minus 2 is equal to 3x, and then divide both sides by 3, and you get x is equal to y minus 2 over 3. X equals y minus 2 over 3 is your answer. Okay, question 9, a ratio question. Ali, Beth and Claire take a test. The ratio of Ali's score to Beth's score is 5 to 3. So we know that 5 to 3 is the ratio of Ali to Beth's score. We also know that Ali scored 10 more marks than Beth. So because Ali has 2 more parts than Beth, 5 to 3, we can say that 2 parts must equal a score of 10 marks. So 1 part, for our benefit, must be 5 marks. Using the ratio up here. We know that Ali has 2 more parts, and that's the same as 10 marks, so each part must be 5 marks. It says that Claire scored 7 more marks than Ali. Well, how much did Ali score? Ali scored 5 parts multiplied by 5 marks, so he must have scored 25 marks in total because he had 5 parts and each part is worth 5 marks. So Claire must have scored the 25 plus 7 extra marks, so she must have scored 32 marks. And what did Beth score? Beth, out of interest, had 3 parts of 5 marks, so 15 marks. So therefore Ali, as we say, scored 25, Beth scored 15, and Claire scored 32. Nice, straightforward, easy 3 marks there. Question 10, expand this. M times m is m squared. M times positive 4 is plus 4m. Simple. 2 marks for that. Very, very straightforward. Factorise fully, we see these every year, 12xy squared minus 6y. What's the highest common factor of 12 and 6? It's 6. What's the highest common factor of x, y squared and y? Well, it's just a y, so we divide out by 6y. 12xy squared divided by 6y is simply 2xy, and 6y divided by 6y is 1, so we get subtract 1. Check your answers in the exam by timesing out. That times that does give you 12xy squared, and that times that does give you minus 6y, so you know you've got the easy 2 marks. Okay, algebraic fractions here. Solve this equation. Now, two ways to do it. I'm going to go with the way I've showed you in a previous lesson. With algebraic fractions, I don't like anything on the denominator. So I'm going to multiply everything firstly by this 3 to remove it. So I'm going to times everything by 3. That would get me on top 3, 2x minus 3 plus all that over 4. X minus 1 over 3 times 3 just gives me x minus 1. And 2 times 3 is 6. Now I don't like the 4 on the bottom, so I'm going to multiply everything by 4 to remove that. That will just leave me with the numerator here, 3, 2x minus 3, plus 4x minus 1 is equal to 6 times 4, which is 24. Now what I'm going to do is expand the brackets. 3 times 2x is 6x, 3 times minus 3 is minus 9, 4 times x is plus 4x, and 4 times minus 1 is minus 4. All of that is equal to 24. Now I'm going to collect, so I'm going to simplify next. 6x plus 4x is 10x, minus 9 minus another 4 is minus 13. All of that's equal to 24. Now I've got a simple two-step linear equation to solve. I'm going to add 13 to both sides to remove this minus 13, so I get 10x is equal to 37, and then I'm going to divide both sides by 10 to get x is equal to 3.7. Hence my answer, x equals 3.7. Okay, moving on to the next question. Factorize n squared plus 7n plus 6. This is a quadratic expression with n squareds, n's, and a number term. So these are the questions where we ask what multiplies to give 6 and adds to give 7. Okay, two numbers that do that are clearly 6 and 1, because 6 times 1 is 6 and 6 plus 1 is 7. So this simply factorizes to n plus 6, n plus 1. Remember, order doesn't matter. You could have just as easily written n plus 1, n plus 6. Same thing. Two easy marks. Now it says hence. Hence means using part A or otherwise, so you can do otherwise, write 176 as a product of its prime factors. Give your answer in index form. Okay, I'm going to do two ways here. I'm going to show you the hence way using above, and I'll show you the other way in case you're stuck. Above, you've factorized n squared plus 7n plus 6 into its factors n plus 1, n plus 6. Could you use that to factorize 176 into its factors? Well, what could you choose for n here to make that side equal to 176? Well, if you chose n is 10, 10 squared is 100, plus 7 times 10 is 70, plus 6 is 176. So this would be equal to 11 times 16. Okay, so you've factorized the 176. But you want it in terms of its prime factors. Well, 11 is prime, but you need to break up 16 to be prime, but 16 is 2 to the power of 4. So 176 is equal to 2 to the power of 4 times 11. That is your answer. Now the other way of doing it was the old school way. Write 176 down. The smallest prime that goes into it is 2. Circle it, and that would leave you with 88. Smallest prime that goes into that is 2. That would leave you with 44. Smallest prime into that is 2. That would leave you with 22. Smallest prime into that is 2. Would leave you with 11. And so therefore 176 is 2 times 2 times 2 times 2. 2 to the power of 4 times 11. Same. But you could have used part A as well. So the answer is 2 to the power of 4 times 11. Okay, question 13, a question on inequalities here. Just going to draw them in so they're a bit... Okay, it says the points in the shaded region satisfy 3 inequalities. One of the inequalities is y is less than or equal to 5. This equation here is y equals 5, so therefore I would agree that the shaded region is y less than or equal to 5. So that equation is y equals 5, so anything below it is y is less than or equal to 5. Which are the other two inequalities? Well, you know what we're going to do? All we're going to do is we're going to work out the equation of each line to start with. Remember, an equation of a line is in the form y equals mx plus c. C is the y-intercept, where it crosses the y-axis, and m is the gradient. Okay, let's do this line here. Where does it cross? Well, it seems to cross at 2. Okay, so it crosses at 2. And what's its gradient? As you go across 1, you seem to go up a half. As you go across 2, you go up 1. So its gradient is a half. So the equation is y equals a half x plus 2. Okay, and we're looking for the points above this line, so we're looking for when y is bigger than or equal to a half x plus 2. So we look above. Does anything look like that currently? Well, nothing quite looks like that. I tell you what, why don't we double both sides of this inequality to get 2y is bigger than or equal to x plus 4. Now are we in a better position? Well, yes we are. We can see that D is this very inequality, so we've got one of them. Okay, let's go on and try and do this one here. Well, where does it cross? It crosses at 3, and its gradient, as you go across 1, you go down 1. So its gradient's minus 1. So this one is y equals minus x plus 3. Does anything look like that above? Well, not yet. So also we're looking for when the shaded region is above this, so y is bigger than or equal to minus x plus 3. Okay, if I add x to both sides, I would get x plus y is bigger than or equal to 3. Them two are equivalent. Does it look like anything above? Well, yes, it actually looks like b, x plus y, is bigger than or equal to 3. Hence, we found the two other inequalities. Okay, question 14. The diagram shows the line A, B, C, and D. The point A is 400, 920. The point B is 250, 620. The line cuts the y-axis at C and the x-axis at D. Work out the coordinates of C and D. Okay, when you see a question like this, the first thing you could probably do is work out the gradient. The gradient m is the difference in y's divided by the difference in x's. Okay, so m, let's write them down on top of each other here. So x, y, these are our coordinates, and they're 400, 920, and they're 250, 620. So the difference in y's is 920 take away 620 divided by 400 take away 250. 920 take away 620, that leaves us with 300, and 400 take away 250 is 150. So divide these two things and you get the gradient to be 2. Okay, so we've got the gradient here. So in our equation y equals mx plus c, we know that y is now of the form 2x plus c. Okay? Okay, now let's try and work out point C. Now, to get from C to B, we've got to go across 250, because C has coordinates, x coordinate 0, and B's got coordinates 250. Now we know the gradient is 2. As I go across 1, I go up 2. So as I go across 250, I must go up twice that, which is 500. So this tells me that C must have coordinates 0 and 620, subtract the 500, which is 120. So C must have coordinates 0, 120. So I know C now. In my equation of the line, I could say therefore that y is equal to 2x plus 120. Now to get this coordinate here, that is when y is 0, because the equation of the line y has suddenly reached 0, y is equal to 0. So I'm solving 0 is 2x plus 120. Subtract 120 from both sides and divide by 2, I would get x is equal to minus 60. So the coordinates of D are minus 60 and y is 0. Okay, next question. 15 says that the first 3 terms of a sequence are a half, 2/3 and 3/4, and the nth term is n over n plus 1. A quick analysis of this sequence to see what's going on. The numerators are going up by 1 each time. The denominators are going up by 1 each time. And the denominator is always 1 bigger than the numerator. It's easy, this sequence to work. The nth term is n over n plus 1. So what's like the 5th term? Well, the 5th term is therefore 5 over 5 plus 1, which is 6. So the 5th term would be 6. You could work out something like the 100th term, which would be 100 over 101. So that's what the nth term does for us. We substitute any number or value in there, and it will give us what the value of that term in the sequence is. It asks us the n plus 1 term to show that it's equal to that. Well, if we know the nth term is n over n plus 1, then the n plus 1th term is simply where we substitute n plus 1 into this formula for n. Because if we wanted the 5th term, we'd put 5 in for n. If we wanted the 100th term, we'd put 100 in where we see n. We want the n plus 1 term, so we put n plus 1 in every time we see n. And we would therefore get n plus 1 over n plus 2, as required. Okay, show that the difference between the n plus 1th term and the nth term is that. Now difference means takeaway. What is the n plus 1th term again? Well, let's look back. It's n plus 1 over n plus 2, and the nth term we're subtracting, we're doing the difference, n over n plus 1. Okay, we're trying to work this difference out. If adding or subtracting fractions is your aim, make the denominators the same. So, what does n plus 1, n plus 2 and n plus 1 go into? Well, for certain, a common multiple of them is n plus 1, n plus 2. A common multiple is when you multiply them both together, you're sure that they both go into that. What did I multiply this by to get this? Well, n plus 1. So I'm going to need an n plus 1 times n plus 1. What did I multiply the n plus 1 by to get this denominator? Well, n plus 2. So I'm going to have an n times an n plus 2. And we're doing a takeaway. Now let's expand the tops. N times n is n squared. N times 1 is n. 1 times n is n. 1 times 1 is 1. Take away, n times n is n squared, n times 2 is plus 2n. Okay, now we're going to do the takeaway. N squared, take away n squared, well that cancels. This here is actually 2n. 2n, take away 2n, well they cancel. And 1 take away nothing is just 1. So we're left with 1 over the common denominator of n plus 1, n plus 2. Exactly as required in the question. Okay, 15c. Two terms of the sequence have a difference of this. What are the two terms? Well, really, we're supposed to use 15 part B. We're supposed to use the fact that we know that the n plus 1th term subtract the nth term is actually equal to 1 over n plus 1, n plus 2. Now, what would I have to choose n to be here to get 110 on the bottom? Well, if I chose n is 9, I would get 1 over 10 times 11, which is 1 over 110, which is required. So if n is 9, the n plus 1th term is really the 10th term, and the nth term is really the 9th term. So the two terms I'm looking for are the 10th and the 9th. Well, the formula for the nth in general was n over n plus 1. So the 10th is 10 over 11, and the 9th is 9 over 10. So the two terms are 9 over 10 and 10 over 11. If you worked out the subtraction 10 over 11 minus 9 over 10, you would in fact, making them over a common denominator of 110, you'd get 100, take away 99, which is 1 over 110. You would get the right answer. Okay, question 16. Given that x squared plus ax plus b is identical to, the three lines here mean identical to, x minus 7 squared minus a, work out the values of a and b. Okay, going from an expanded quadratic to where the x is in brackets and it's squared with another number, it's called completing the square. This process is called completing the square. So what I'm going to do is I'm going to start off on the left hand side and try and complete the square. Remember, you put your x in brackets with a square outside. The sign in front of the sign of the number in front of the x you put in here. You halve the number in front of the x, so a over 2. You square this number here in your head and you subtract it. So a over 2 times a over 2 is a squared over 4. So you subtract a squared over 4 and you plus your remaining number. You plus your remaining number here. And you know all of that is identical to the right hand side, which is x minus 7 squared minus a. Okay, let's see what we can do here. Well, because these two sides are equivalent, this here, this x minus something squared must be the same as this x minus something squared. So we could say that therefore a over 2, this bit here, must equal this bit here. So a over 2 must equal minus 7, so a must equal minus 14. So we've got our a to be minus 14. Okay, but now we know if a is minus 14, we also know that this here must equal this here. Okay, so we know that minus a squared over 4 plus b must equal minus a. But a is minus 14, so let's put that in here for a. So we've got minus 14 times 14, and over here we're going to have 14 over here. Minus 14 is that. We're going to have b is that. Now 14 times 14. If you want to do 14 times 14, 4 times 4 is 16. Put down the 6, carry the 1. 4 times 1 is 4. Add the 5, 56. 0, 4, and 1. So you're going to get 196. So this here would be minus 196 over 4. Okay, let's keep solving from there. Minus 196 over 4 plus b is equal to 14. Well, 200 over 4 is equal to 50. So 196 over 4 must be 49. So this is minus 49 plus b equals 14. Add 49 to both sides and you get b is equal to 63. So B is equal to 63 there. Now, a very difficult question, quite confusing there, but you're completing the square and making things equal to each other. There is another way of doing it. Let's have a go at another way of doing it here, just to make sure we've got different access to these questions. If we actually expanded out the left-hand side, so if we actually expanded out the left-hand side, so we worked out the left-hand side is equal to x squared plus ax plus b, okay, no expanding needed, and we expanded out the right-hand side, so we're working out x minus 7 times x minus 7 minus a. X times x is x squared, x times 7 is minus 7x, minus 7 times x is minus 7x, minus 7 times minus 7 is plus 49, and minus a. We would get that we have x squared minus 14x plus 49 minus a. So if we compare the left hand side, which is x squared plus ax plus b, to that, we can clearly see that a must be minus 14, this must be the same as this, and similarly 49, b must be equal to 49 minus a, which is 49 minus 14, which again is equal to 63. So that was probably a much easier way of doing it in that particular case. A is minus 14 and b is 63. Here is a formula. R is the square root of w squared minus h squared. Work out the value of r when w is this and h is this. Okay, the first thing I'm going to do is actually, if I want to work out r, the first thing I'm going to do is work out w squared. Okay, w squared is 9 root 2 squared, which is 9 root 2 times 9 root 2. We could do the numbers multiplied by each other first. 9 times 9 is 81. Root 2 times root 2 is root 4, which is 2. So that's 81 times 2, which is 162. Let's also work out h squared. Well, what's h squared? H squared is equal to 5 root 6 squared, which is 5 root 6 multiplied by 5 root 6. 5 times 5 is 25. Root 6 times root 6 is root 36, which is 6. And 25 times 6 is equal to 150. So now we could work out what r is. R is the square root of w squared minus h squared, which is the square root of 162 minus 150, which is the square root of 12. So we've worked out what r is, but it wants your answer in the form a root b, where a and b are integers. Can I think of a square number that divides into 12? Well, yes, I can. 4. So 4 times 3 is 12, and this simplifies to root 4, root 3, which is 2 root 3. Hence your answer, 2 square root 3. Okay, question 18, the last one. Solve the simultaneous equations. Y squared is 2x plus 29, equation 1, and y equals x minus 3, equation 2. One's quadratic, this one's quadratic because it's got a y squared in it. That's quadratic and that's linear. When you're solving a quadratic and linear, easiest thing to do is by substitution. So I'm going to substitute y is x minus 3 into equation 1. So where I see y, I put x minus 3 instead. So that would read out x minus 3 squared is equal to 2x plus 29, which means x minus 3 multiplied by x minus 3 is 2x plus 29. x times x is x squared, x times minus 3 is minus 3x, minus 3 times x is minus 3x, minus 3 times minus 3 is plus 9, that's equal to 2x plus 29. Tidy up, x squared minus 6x plus 9 is equal to 2x plus 29. I've got a quadratic equation because I've got an x squared and I've got an equals, but to solve I need to make the quadratic equal to 0. So I'm going to subtract 2x off both sides and I'm going to subtract 29 off both sides. So I get x squared minus 6x minus another 2x is minus 8x, and 9 take away 29 is simply minus 20. That's equal to 0. Now I need two numbers that add up to minus 8 and times to minus 20. What would those two numbers be? Well, with a bit of luck and a little bit of thinking, you could say to yourself, well, that must be x. It'll be minus 10 and x plus 2. So on the one hand, we've got two numbers multiplying to 0. X minus 10 must be 0. So x must be 10 or x must be minus 2. And substitute back into this equation here to work out what the y must be. Y must be 10 minus 3, which is 7, and y must be minus 2 minus another 3, which is minus 5. So that is one set of answers, that is another set of answers. In the exam, substitute back into both equations to check they work. Thank you for listening to this video. I hope you found it useful in your revision.